Hey guys, welcome to this video. If you're here, it's probably because you're planning to take the November SAT, or maybe you're still planning to take the October PSAT, or maybe you're even planning to take the December SAT. Before we get started, note the disclaimer listed below, and also note that if you're looking for more prediction videos, make sure to check out our playlist. We have hundreds of problems in there, including what is coming up for the upcoming exam. Number two, make sure to hit that like and subscribe button to make sure you're well prepared for upcoming videos. And let's check out the problems listed here. Okay, so in this problem, we're talking about power. And you're talking about this idea of multiple variables, and we have an equation. And this equation becomes frustrating because you are here reviewing the problem and it's exam day and you're like, I've never seen this equation before. And it looks like a physics problem and I haven't taken physics. And that's what they want you to do. They want you to worry about the problem you see. But here we go. We know that they tell us two things, what the variables are. One, voltage, and two, resistance. And they tell you this when you're reading the problem that, okay, volts is for V and resistance is for R. And they tell you they're comparing two circuits, the first circuit and then the circle's second circuit. Okay, so we have two different circuits that we're comparing. This isn't technically a physics problem. They just give you a ton of variables that you're expected to know what is what. And they let you know in the problem that they have volts of the first one and the volts of the second one and resistance and then resistance. So what does this mean? So the circuit, if you notice, is the same thing as power. And this is where it can get tricky because you might be thinking, what is circuits? They don't tell us that. They do technically, they say circuits and then they say electrical circuit and then they let you know that's the variable P. So we're comparing this equation of the first circuit to the equation of the second circuit. So first, let's tackle this first circuit. So if we take a look at P1, which is our first circuit, we know that the equation is V squared over R. In that first circuit, we know that it's just V, so it's V squared. And then they tell us the resistance is just R ohms, so that's just going to be R. Then in the second circuit, they let us know that that would be P2, or second circuit, I should say, and that's going to be 3V. This is all part of that V is squared over the new R, which is 2R. So we're comparing the ratio of essentially P2, because they say in the second circuit, to the first circuit. So they're technically saying P2 to P1. What is that? And if we go ahead and first, I would reduce this a little bit more to reduce to distribute the square. So 3 squared is 9, and that's V squared over 2R. So that's P2. So we have 9V squared over 2R over our first circuit, which is this V squared over R. I'm going to reduce this. Now I'm going to do this the long way just so you see. You might automatically know because you've done problems like this before. But remember, we have 9v squared over 2r, and we're flipping that with the times table to say it's r, right, over v squared. And we can go ahead and get rid of the r's. We can get rid of the v squares. And then we just have 9 over 2. So that is going to be choice C. So the correct answer is C. Now, automatically, if you've done a bunch of problems like these, you know that if you just have v squared over r, v squared over r, these just eliminate each other. So you would just be left with 9 over 2 if you didn't want to do it the long way, and you would just automatically know it's 9 over 2. But this is a problem where you're given a scenario with multiple variables where they give you some hypothetical situation that you're not aware of, like a physics or a chemistry-based scenario, and you're expected to take the formula, not the information that you would know from physics or chemistry and just plug in the variables that you have and deduce when they're talking about circuits, they're talking about power, and they're asking you just to compare. So this problem is comparing ratios and also your understanding of interpreting what they're asking for. Let's try to solve this problem that you see on your screen here. We're going to try to solve it using Desmos, but we're going to have to try to interpret what the problem says before we actually plug it into Desmos. So firstly, they say there is a product of two positive integers, and then they give you a value. We're going to call these variables x and y. Because they're saying product, they're designating this as multiplication and letting you know that the value is 506. They're also letting you know that the first integer, I'm going to call this x, is 4 greater than 3 times the value of the second integer, which we're going to designate as y. So what they're trying to let you know is x is means equals 4 times greater. So 4 times greater. So that designates addition. So we have x equals 4 times greater, then 3 times the second number. So they're saying 4 plus 3x because they're talking about the second number, I should say y, being y. So to recap, we have we have a product with two positive integers. We've designated this as x and y, and that equals 506. And then in the second equation, they said that the first integer, which we let you know is x, is greater than 3 times the value of the second integer, which is y is the second integer, so 3y. What is the smaller of the two integers? Technically, you want to plug one into the other and solve, but the value is rather high. So let's think about it this way. If we go ahead and plug in this equation into the value of x here. So essentially what we would have is something like y times the value of x, which is 3y. I switched around the variables because it's 3y plus 4, or 4 plus 3y, either one, but I wanted to just switch it around just for ease of watching, equals 506. So you have y times 3y plus 4 or y times 4 plus 3y. Either one works. I just wanted to move it around this way, once again for ease. I'm going to go ahead and distribute my y here for both of them. And this means that my y equals 3y squared plus 4y. I'm going to go ahead and say that there's also the other y, which we now know to be 506, the other equation. So I can plug that into Desmos, and I can go ahead and say my first equation as because there's two y's, f of y equals 3y squared plus 4y. And then I have a second equation, which I'm going to designate as g of y equals 506. So you see I plugged that into Desmos because I had my two lines. And because I'm trying to utilize Desmos, I'm going to use f of y and g of y so it knows that it's two separate lines. I can zoom out. I zoomed out ahead of time. And when I do that and click the point of intersection, it gives me the value of 506, comma 1238. So it shows an intersection around 1236. And then if I zoom out more just to show it again and zoom in a little bit here, you could see that 12.337. So I'm going to go ahead and erase what I have here, which blocks it. So let's see here.
so we could see what our equations are and the point of intersection. So if you go ahead and you zoom just a little bit and you click it, you see the 506, which is our x, and what's the y value? Around 12.337. Because we're talking about the smaller integer, you're going to go ahead and say it's around 12 if you're going for the nearest whole number. So you would say the answer is around 12. So to recap, the original problem was, if you go ahead and you take a look at what we had here, it said the product of two integers is 506. What the first integer is 4 times greater than 3 times the value of the second one. What is the smaller of the two? You know that you have one of them being 12, and that is your y value. If you go ahead and again, if you take 506, if we were to clear this out for a second, and say 506 divided by 12, we would say the bigger one is around 42. So we want to find the smaller of the two integers. So we know that the smaller one is going to be around the value of 12, sorry. So to correct what I just said, you want to note that there's two integers. When we found the point of intersection, we found that it was around 12 point something, 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 which was either X or Y. And I had to plug it back in, divide it by 506 to figure out the other variable to ensure that it's the smaller of the two, because that's what our problem says. And it said that the larger one was 42 point whatever. So in this case, the whole number that it's closest to is 12. So I'm going to state that the answer is in fact 12 as our proper answer if this was an open-ended question.
Let's tackle this problem together. We know that they give us some sort of trigonomic identity, and they let you know that x is 60% greater than y. I want you to think of a triangle where, let's say, it is some sort of right triangle. We know that the sums of the other two sides have to equal the leftover 90 to give us 180 degrees. So we know that two of the angles has to be the leftover. So we also know, based on the trigonomic identity, that sine of theta is the same thing as saying cosine of 90 minus theta. So we can essentially say that these two, which are equal to each other, has to be that leftover that's equal to 90 degrees, right? So we can say that the angle x, say this is x and this is y, so x plus y has to give us 90 degrees. And we also know that they let us know this is not an equilateral triangle because they say one of the sides is greater than the other. So all sides are not the same. And the other thing we know is it's not going to be where two sides are the same because one is greater than the other. Knowing this, we now can say that x is 60% higher. We're essentially saying that x is 60% higher, which is 1.60 because we have 60 plus the 100% y. When we go ahead and take a look at this, we can go ahead and present that into the problem. So we could say this is going to be replaced with x, giving 1.60y plus y equals 90. And we can simplify this further. We have 2.6y equals 90. Divide both sides by 2.6, 2.6. X ends up giving us, or I should say y, ends up, because we divide both sides and we're solving for y, gives us 34.615 dot 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 if you plug that into Desmos. I'm going to go ahead and plug that back into my equation, this one specifically, because I am solving for the value of x. So essentially I have 1.60 times my y, which is 34.615. And I get something like 55.38 because I want to round to the nearest tenth, and this is an open-ended problem. My final answer will be 55.4. So this involves knowing your trigonomic identities and plugging and chugging to solve.
Appreciate you riding along for our cosmic journey. If today's Shade brought you the knowledge that slaps, make sure to hit that like button to boost that signal. Subscribe if you're locked in for our next launch. And don't miss the link tree. It's got all the goods for AP Bio, PSAT Math, and SAT Math. Before I sign out, make sure you're all in one orbit and diving in. Killing out. Till next time.